sir.
No, sir, it's not visible to us.
Okay. I don't know what is the problem. Then I will create a new link actually. Okay.
Yes, sir, that would resolve the
But
issue.
it's okay if it is audible, then it's okay. I will create a new link. I think there is some problem with this link because no such type of options is available that enable the chat box to the attendee like this. It is not available here. I tried, I looked up at all the options available, but nothing is here like this. Someone is requesting from the first one the link. Tell them to join with the second link. Okay, that will direct you directly in this lecture. Otherwise, let me erase this post. Okay, so that no one will go with this. Okay, so how many students now? It's 73. Okay, so we can start the lecture right now. Who is Nikhil? I think he is trying to join from another email ID. Nikhil. Okay, so let me present the screen. Is the screen visible?
Yes,
Yes,
sir.
sir.
It is visible, sir.
Yes, sir.
Okay. Nikhil, kindly mute your mic. Nikhil. Nikhil.
Just a second, sir. So just a second, sir.
Nikhil, am I audible to you? Hello, Nikhil. Okay, let me start the presentation. Okay, so is the screen visible right now?
Yes, sir.
Yes, sir.
Okay, so this is the very first lecture of this fluid mechanics. This is your fluid mechanics first, basically. So first, because you are going to cover the fluid mechanics second in the next semester. Okay, in the fourth semester, I think. Okay, so this is your fluid mechanics first. So it will contain some basic, then some advanced topic also is there. Okay, so let me first introduce the some basics of this fluid mechanics. Okay, which will require during our course. Okay, so let me introduce you the about the subjects. So first of all, the objectives. Why we basically study this fluid mechanics. Okay, So first of all, we know that there is a huge application of the fluid mechanics surrounding us. All of us, we know this. So all the objective basically is to fulfill that. How? Let me spell out one by one, okay? To understand the basic concepts of the fluid mechanics means the basic concept of fluid mechanics means this is specifically for this fluid mechanics one. Okay, means that fluid mechanics one will include the basic concepts also. Okay, and then we will go with like the difference between states of matter. States of matter means like solid, like fluid, and then we have gas like this. So we will discuss briefly. Then recognize the various types of fluid mechanics application encountered in practice. Then also have a working knowledge of the importance of dimensions, units, and dimensional homogeneity in engineering application basically. So this is the objective of this today's lecture basically. And overall, your this fluid mechanics will goes with the all this like the means the what is the basically the what is this fluid mechanics, what is their mechanical point of view means from the mathematical point of view also we will cover in these subjects, but today's lecture will be based on this basically the basics of this fluid mechanics, basic difference, and some applications of this. So first of all, what is this basically the mechanics first? Because we know that in the fluid mechanics, we are going to use the mechanics, but that mechanics will be associated with the fluid. Okay, so mechanics means the oldest physical science. We all know this. Okay, whatever I will told, I know that mechanics everyone understand that oldest physical science that deals with both stationary and moving bodies under the influence of forces also. And then the definition of this mechanics, if you will see here, there is a definition of, uh, let me take the laser point. Okay. So here we have this. Is the laser point visible? Hello,
Yes, sir.
students.
Yes, sir.
Yes, sir.
Yes, sir. Yes.
So as
It is
here you can see that we have the stationary and moving bodies both. So stationary basically means the static conditions. Stationary means the body or the fluid. If we are discussing fluid, then obviously our concern is fluid. It means the fluid will be in static condition, no motion. Like just if you will take an example, then it is like the one full glass of water just kept on the table. So it is in static conditions. There will be no velocity and acceleration types of parameters there. What will be there? It is only the pressure. The pressure applied due to the fluid. So that is the stationary case. And then we have another case that is called the dynamics. Means the moving bodies. So here we have this static. So it is that branch of mechanics that deals with the bodies at rest. Rest means the velocity is zero. If velocity is zero means all the moving parameters, which means which defines the movement, will be zero. Like velocity, acceleration, all this. Then we comes dynamics means when your body is in moving conditions. Means the equation. Okay, means how it will come to know that okay sir this is statics. Okay, आप देख रहे हो, you are looking the static examples. Okay, like one glass of water on the table. But what is the parameters? What is the equation which will be applicable there? The main concern is this. Okay. So main concern is this. What is the equation, governing equation which can govern that condition of statics? And what is the equation which can govern that dynamics? Okay, this is the main concern to study this fluid mechanics, and that what we are going to cover during our course. in the future lectures. Okay, that is the main goal. Okay, so dynamics means the equation which govern the motion of the fluid will cover that properties like velocity, like acceleration, like this, like force, all this. So the dynamics means the science that deals with the behavior of fluids at rest or in motion. So that is mechanics. But dynamics in that static and dynamics is differ from the point of view of their governing equations. Like if it is static, then velocity will be zero. If it is dynamic, means it is in motion, then it will be, there will be the term like velocity, acceleration, all this. So fluid mechanics deals with both.
Excuse me, sir.
Yes,
So the body moving with uniform velocity is come under static condition or dynamic condition?
moving with,
Uniform velocity, which is not changing.
okay, that is also
Yeah.
dynamic. Your body is moving. That condition will be different. Your equation may be differ. It is not a
Okay.
static actually.
Okay.
Okay,
Sir, in stat
their equations will be different.
Sir, in static and dynamic, we have different equations. So if I am dealing
Static,
with an, so if I am
dear
dealing with an
students,
yes, sir.
let us complete the parts. Don't be very much anxious at this time, okay? What you are saying that static, there is a very different conditions. If your body is moving, means what is your reference point?
Sir, so basically we take a reference point, then say that it is static or dynamic.
If your velocity is constant, then okay, your acceleration will be zero.
No, sir, I am saying that if a body is moving and I am also moving with same velocity and acceleration, then for me it will be at rest. So it will be static or dynamic.
No, if with that reference, it will be your static condition. So what you are talking is basically for the solid mechanics type of case. Okay, means for defining the static condition, for that case you have to take the frame of reference. In that frame of reference, that will be statics. आप एक चीज छोड़ रहे हो उसके साथ कि we have to take a frame of reference. And what that I know that covered in the 12th, I think, standard intermediate classes.
Yes.
Include that frame of references also. What? Then your answer or question will be complete. But you will not find such
Yes,
type
sir.
of cases everywhere. Okay, try to understand. Okay, now this is not your your 12th class. This is basically the engineering applications, and I am not saying that will not be the case, but this is only a specific condition. Okay, this is only a specific conditions. But so
Yes.
let us discuss. Let us complete this. Okay, there will be conditions for every specific situations. So don't worry about this. Okay, just at the very start of this class, it will disturb the class actually. Okay, let us complete. You will get your answer in the future lecture. All the answers you will get. Yeah, I think after completing the sections or chapters, you can itself understand. Okay, this will be your conditions. Okay, but first of all, we have to complete the parts, at least some parts. Okay, so now this is your static and dynamics. First of all, this is your fluid mechanics. Then fluid mechanics is divided in the basically the two parts. But further, that dynamics part is divided into the further one, and there is another class that is called the kinematics. Okay, so in the kinematics, what happens? We do not include the reason, the cause of the motion. What is the cause of the motion? It is the force. If the force from both the direction will be same like this, like if the pressure is same at the two different in the fluid, okay, that it is the pressure which govern the flow basically. So that's why I'm taking the example. So if the pressure between the 2 points will be same, then there will be no flow because there is no difference of the force like this. So in the kinematics part, what actually happens, your governing equation will not include any force term. Means force, which is the reason of the motion. So the reason of the motion is not, will not be included in that kinematic, is not included in the kinematics equation. What will be included? Yes, because kinematics is also deal with the motion. So yes, there will be like acceleration, like velocity. So this kinematics is also, you can say, a different approach of study of this fluid mechanics. Okay, so you can say that this fluid mechanics is divided into three parts, like static. Okay, so first we will cover the static in our course. Then we will discuss like kinematics, then dynamics like this. Okay, so it is divided in the static, kinematic, dynamics. And yes, that static means totally rest. But yes, kinematics and dynamics is deal with the motion. In the kinematics, force is absent. In the dynamics, force is included. So that is your kinematics, statics, kinematics, and dynamics. That fluid mechanics will cover this three part. Then these are the some another type of studies which is very related to the fluid mechanics. The concepts of this fluid mechanics is related to this also, like hydrodynamics, the study of the motion of fluids that can be approximated as incompressible flow, such as liquid, especially liquids actually. Gas, consider hydrodynamics at a very low speed. I think it is mentioned here, if you will see, because gas is very much compressible. It means, let us take an example. A balloon is full of air, you can compress it easily. But when you will fill water, you hardly compress this. It will compress, but will be very, very small, negligible types. Means any liquid, you can say, not like, not only water, means liquid is less compressible. So compressible basically means when density change. When you compress anything, their density changes. Okay. So hydrodynamic means when your study includes incompressible type of flow. Means density will be constant like this. Negligible change in the density. Hydraulics, it is like a subcategory of hydrodynamics which deals with the liquid flows in pipe, open channels, this type of flow basically. This, all these part actually included in the fluid mechanics. Means these are the, you can say, the sub parts of the fluid mechanics, hydrodynamics and all, hydraulics, then gas dynamics. That also includes the concepts of the fluid mechanics. So gas dynamics means sometimes we consider compressible flow. Okay, but with low speeds it is not considered, like deals with the flow of fluids that undergo significant density change. So compressible means density change, means the fluid, you can say the gas which is compressed. So compressed means density change. So such flow of gases through the like nozzles, and means we have a very good number of application of this gas dynamics also. Then aerodynamics, that also includes the fluid mechanics, that deals with the flow of gases especially, like yes, in aerodynamics, yes, it is very or to mention that aerodynamics is basically means the medium, means the fluid is basically air, that's why it is called aero. Okay, and dynamics, you can understand itself, dynamics means the motions. So over a body such as aircraft, rockets, means what we have, that like aeroplane, helicopters, missiles, all these automobiles. Okay, that comes under this aerodynamics section. Okay, all these are the dynamics. It means that aerodynamics is itself is a very vast area, and it is so vast that there is a separate department of aeronautical like this. Okay, and along with this you will find like meteorology, oceanography, hydrology, so that deal with like the naturally occurring flows basically. There is also a fluid, so these also covers okay, but here meteorology, oceanography, like this hydrology and aerodynamics, and also the gas dynamics. Okay, last three, that gas dynamics, aerodynamics, meteorology, oceanographics, these are not the scope of our fluid mechanics basically. Okay, there are separate, you can say separate subjects, okay, for these gas dynamics, aerodynamics, okay, because these are itself a vast area: gas dynamics, aerodynamics, meteorology, oceanography, and some parts like aerodynamics, oceanography, it is so vast that there is a separate department actually, okay, but all these are related to this fluid mechanics basically. Okay. So let us, what is this fluid? Okay, so yes, we are going to deal with the fluid. So we have to understand the behavior of the fluids. Means what is this fluid basically? A substance in either in the liquid or gas phase. Both are called the fluid. Okay, and you can say the fluid which has a tendency to flow. So liquid and gas both have a tendency to flow. Okay, whatever the small forces like shear forces applied. Solid can resist an applied shear stress by deforming. Means suppose you have a you have a solid object. So that solid object always resist the motion. Okay. That resists the motion. Means if you will try to compress, that solid will not deformed until unless our elastic limit force will cross. After that it can damage. But up to that limit, up to that means there is a good limit of the force which a solid can resist, but that not happen so with the fluid. Actually fluid deform continuously under the influence of a shear stress, no matter how small, whatever the small, the fluid always deform. If you will put the fluid, it will start flowing. Okay, so it is said that fluid always means continuously deform. In a solid, stress is proportional to strain. I think all of you are familiar with this. But in fluid, stress is proportional to a strain rate. There is a strain rate. Why strain rate comes? Because that fluid always in motion. Motion means there is a velocity. And when the velocity comes, so what is velocity? It is meter per second. It is meter per second. So always it counts in the terms of velocity. And when the velocity comes, it is like meter per second, but in a strain it is like in the meter. But in the velocity, due to its continuous motion, it is like velocity means meter per second. Means what is the changes in that length with time basically. Means deformation with time. Why deformation time? Because fluid is always in the motion. Means with it always contains some velocity. So that's why added there, okay, during the deformation of the fluid. So that is why it is called that stress is proportional to strain rate basically. When a constant shear force is applied, a solid eventually stops deforming at some fixed strain angle that we know. Whereas fluid never stops deforming, it approaches a constant rate of strain and it will deform like this. So deformation of, like here we have a figure. Okay, deformation of rubber block placed between the two rubber, to place between two parallel plates. Okay, under the influence of shear force. So we have here a shear force basically. Look at this. This is our shear force. Shear force. I hope all of you are aware of the shear force. A force which is parallel to the surface. Okay, that is called the shear force. Also, you can call tangential force. Okay, which is tangent to the surface. Okay, so shear force shown here, that means on the rubber, an equal and opposite shear stress obviously will act on the upper plate. So that is the concept, means how this deformation comes into the picture. So the same things happens, like let us suppose if you have at the place of rubber, if you have a liquid, so it will deform like this. Okay, due to this, means here we are generating the shear stress, but what happened, the phenomenon will be same, but okay, but fluid always try to deform. So this is basically, that figure is basically to give exposure. That means how the shear stress is come into the pictures. Okay, and this is your shear strain basically. That alpha means the change in the angle. Okay, I hope this part is covered in the solid mechanics. I think all of you are aware of this, means how this shear stress. But I am just exposing this to you. Means just a revise so that we can cover this in the future. Now then come obviously when force acts. So another term come into the picture, which is called the stress, that is force per unit area. Here in the fluid mechanics, when you consider your force over a particular area, obviously it will be a stress. Okay. And again, normal stress, shear stress. Okay. So normal, all of you are aware of. I think normal means means perpendicular to the surface, and tangential means which is parallel to the surface. Okay. And pressure is always a normal stress. Pressure is also a stress. Okay, pressure is also a stress which always act perpendicular. Means pressure always act perpendicular to that particular surface. Always. Pressure is a normal stress basically. Okay, in a fluid at rest. So zero shear stress, a fluid at rest, obviously zero. When will be zero? When your fluid is at the rest, means when there is a no motion. So there will be no deformation. So when there will be no deformation, means when there is a shear stress forces, sorry, the shear stress, if shear stress is zero, there will be no deformations. Okay, so this is called the zero shear. Zero shear stress means it is in a rest condition basically. Zero shear stress denotes the condition of rest basically. When the walls are removed or a liquid container is tilted, a shear stress develop. Obviously, when you are disturbing, okay, suppose you have a glass of water, and when you start tilting that glass, obviously you will find that the liquids layers started deforming. One will move back, one will move come forward in comparison to each other. So fluid which is in contact with the uh, like container and which is on the upper part, you will find that there is a difference between their motion. One is ahead of the another. So there is a physics behind this that we will cover in the future. Okay, but that these are the phenomena, means how this stresses come into the picture in the fluid mechanics, and that this is what we are going to cover in the future lectures. All these are facts. All these phenomena we are going to cover. Okay, so these normal stress and shear stress at the surface of the for fluid at rest, the shear stress is zero. That means and the pressure is the only normal stress in that condition. Means when your fluid is at rest, basically what this is trying to say, when your fluid is at rest, there will be no shear stress. The only stress is the pressure, which is basically a normal stress. Meaning pressure is a normal stress in case of uh, rest. Then comes a concepts of the liquid and the gas. Actually, I think all of you are aware of this. That let me give this very fast. This means these slides. Let me explain this slide very fast. Liquid basically generate you can say a surface. Here you can see here there is a free surface. Liquid has a capability to generate a free surface. You will find that okay, yes, over the if you have a glass of water, you will find that there is a surface. But the same you will not find in the case of gas. The reason is the cohesive force. In the case of liquid, the cohesive force is very large. In the solid, it is much larger. But here we are taking the fluid case, not the solid. Okay. So in the liquid, your cohesive force is large. In the gas, your cohesive force is very small because there is a very wide space between the molecules. And in the liquid that space is very less. So that cohesive is a force. I think all of you are aware that the force of attraction between the same molecules. So that is very small in the case of that gas actually. Due to which what happens, that gas is not able to generate the free surface because due to that less cohesive force, the molecules started to take the shape of the container because it is free to move because there is no force which can bind their molecules. So they are free to move, and due to this, that gas doesn't generate any free surface. Whenever you will open the container, it will goes out of the container. It will tries to fill the uh, container, means the space basically. So when you open, it will try to fill the room. Okay. So that's why the gas doesn't generate any free surface. But yes, a liquid generate the free surface due to the large cohesive force. Okay. And due to this reason, what happens? The another phenomenon, liquids always takes the shape of the container because there is a gravity force. So due to that gravity force, due to that gravitational effect, the liquid generally takes the shape of the container in which you will keep that liquid. But that not happen with the gas. When you will put the gas, and if it is not closed, it will just go out. It will go out and it will like it means it will like try to fill the space, whatever the that space, like environment, like room, whatever it will always try to fill. So that happen means these are the phenomena. So some difference between the liquids and gases. These I think these are the things which all of you have already studied. I think okay, like means the arrangement of the molecules in the solid. You will find some a compactness. I think in the liquid there is some means it is not so compact like as like the solids, and gas as we have discussed that the gas the space means between the molecular space you can say that is very large due to which the fluids in a random motion okay in their uh, space on so this is basically actually the lattice arrangement I think okay means the and that which represent basically the intermolecular bond actually, so that intermolecular bond is very strong in the case of solid okay and then in the liquid and then in the gas. So in the gas it is very small, and I think that's why they always try to fill the space. So these are the arrangements of these different phases you can say that molecules at a relatively fixed position in the solid you can see. Okay, so that you can go with the means the same things but what I am saying is written there. Okay, so these are the some basics actually the concepts of this. Now gas and vapor are often used as synonyms for gas. The vapor phase of a substance is customarily called a gas, vapor phase, when it is above the critical temperature. Yes, obviously, every liquid can change into a gas above that. There is a critical temperature, which means above that temperature, liquid can change to a vapor, or you can say the gas. Okay. So these are basically some like the macro or classical approach and micro and statistical approach actually. So we have the two actually the two approach of a study generally which follows in the studies. Okay, what is that two approach? That is the macroscopic approach, which is called the also called the classical approach. And then there comes a microscopic, which is also called the statistical approach. If you will see here, okay, so this is your macroscopic and this is your microscopic. Now, the question, the very next question comes in the mind, what is this macro and microscopic? Okay, the very next question should be from the student side. Okay, actually here the insight of this macro and micro is not written here basically, but I will I'm explaining you about these my macro and micro. Actually that doesn't require a knowledge of the behavior of individual molecules. Means when you are studying an individual molecule, like let us take a picture here. Okay, in this picture you can see let us means take this as a individual molecules that these blue dots which is available in this container. Okay, so here we have a number of molecules. So if you are studying each and every molecules, then it is called this microscopic. Okay, that's why it is called microscopic, because you are studying at a micro level. Okay, that's why it is called microscopic. Now my question is, What is the number of molecules? How many means number? It is like 6.23 like into 10 to the power. Like Avogadro's number means for a particular like 1 mole like this. So you can imagine how complicated it is to study that number of molecules, each and every molecules. You can understand. Okay. So that's in that case, but there is a microscopic study also, but it is a very advanced level. Okay. To study that, obviously, what we need statistics, because a normal approach doesn't apply there. I mean, a normal theory is not applicable there for such number of molecules. So we always use statistics there. If you have studied the statistics in your previous class, then you can imagine just right now. You can imagine that why statistics is used. So statistics is used to arrange a very large data. So for study of this microscopic, we need this statistics. That's why it is called microscopic, either microscopic or statistical approach. That's why there is a two name, micro and statistics. So this is your micro level, and in the macro, what happens? We take the container itself, not the molecule. Okay, and we apply a general laws or theories, and then we come out with the result. In that case, it is called macroscopic, the classical approach. And this is our concern, macro. Means we are going to follow this macro approach in the fluid mechanics, not the micro. Micro is the advanced level study. Okay, I mean, you will either find in the BTech or like the PhD type of work. You will not find micro everywhere. I think there is very less people with this specialization, micro. So what we are going to cover, it is macro. We are going to like take a control volume. I will discuss. I think you are aware of this control volume. We take the control volume, we apply the principles there, means the laws like conservation, you can say the conservation principle, and then we come out with the results, means the equations. So that is your two. That is what we have the two approach, the macro and microscope. Okay, yes, these are the some application of this fluid mechanics basically. So fluid mechanics is applicable. I think there is abundant applications. These are the few actually. Okay, that like this first picture is actually represent the application of this fluid in the uh, uh, body of the human. Means not only human, means every human living being's body, you can say. Okay, which is called basically the biofluid mechanics. Okay, so that fluid mechanics has their own application in the biology also, you can say. And of course natural flow we already know. And this picture represents the dam construction lines. So in the dam construction there is the concept of static is utilized there. Not only the statics, okay, but yes, dam is built up with the concepts of that statics actually. So this is the one of the example. And here, yes, the power plants and then aerospace, automobiles, process industry, means in the chemical engineering. I think that fluid mechanics is also studied in the chemical engineering department. Okay, some part is different, but I think 70-80% of the syllabus will be same, you will find. And then wind turbine. Okay, process industry basically means where that the process occur. Like take one example, like the you can say the milk plant. Okay, so that is one of the example of process. There are a number of process industry. Means process means like that, like milk plant. Okay, so these are called the process industries, where there is a piping system. So why piping system occurs? Obviously, if you will find there is a piping system, it means obviously we need pipe for the fluid, okay, not for the solid. So whenever you will find pipe, you can easily understand, obviously there will be a work of fluid. Okay, that is the medium will be fluid which will flow through that pipe. So these are means the application of this fluid mechanics. But these are the few, but there are another applications also. As I told you that there is a terminology. generally, which is utilized in the fluid mechanics. I think all of you are aware of this, I think, from the thermodynamics, right now? All of you are aware now of this system and control volumes? Just confirm me.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Okay, but I will take a quick revise actually. Okay, system means the quantity of matter or a region in a space chosen for a study. Like here, if you have chosen this red dotted line, you can see here. So if you have chosen that region, so it will be your region of study. Okay. So that is basically called the system, and whatever the surrounding of your system is called means like the mass region. Whatever the surrounding outside that system is called the surroundings, and the boundary means like this dotted line. You can say the boundary. Okay, means the boundary means boundary which surround that system. That is boundary. It may be yes, it may be real imaginary. It actually depends on you actually. Whatever the parts you are considering for your study. Okay, so for a study purpose, sometimes you will find. I think if you have studied this, then you can imagine that we have take a imaginary line. It's considering that this is the boundary. Okay, so that can be real and imaginary. So real means yes, there will be a boundary like wall. Okay, and imaginary in the case when you are applying some your theory inside that wall. So that then you have to consider an imaginary line. So that's why it is called real and imaginary. It can means boundary can be real and imaginary. Okay, so boundary of a system can be fixed or movable like. In a means one I am taking one of the example like in a piston cylinder and piston, all of you are aware now what is piston and cylinder.
Yes, sir.
Yes, sir.
Okay, so that piston and cylinder basically utilized in the automobile sector. So there actually what happens, their boundary is in a motion. Okay, and like one glass of water is a fixed boundary. So that is means the example of the fixed and movable. Okay, so your boundary means your boundary can be fixed and movable. The basic means the main constraint of this line, and the system may be considered like closed and open. Yes, means when your particles is moving means your if your medium is moving out of the system, then it is called open, and if it is inside that system, then it is called closed. Means if there is an exchange of mass, basically, if there is a means in with a very technical sentence, if there is exchange of mass, then it is called open. If there is no exchange of mass, then it is called closed. So we have the two type of system, closed and open. Okay, like here in this example, you can understand that this is the system, and this is the dotted line is the our boundary, and whatever the surrounding of this boundary is called the surroundings basically, and means the closed system means the closed system means when your the mass is there is no exchange of mass, means mass is fixed like this. Okay, mass will not cross the boundary. Like here you can see here mass is not getting out, it is like fixed, but yes, energy can be out. Why energy is out? Because it is not insulated. Okay, so we can exchange the energy, but we can fix the mass. So such type of system is called the closed system. In open system, both energy and mass getting exchanged. Okay, and then comes another like insulated. But here, I think in our case, insulated it means in the fluid mechanics, insulated is very rarely used. It comes in like in the thermodynamics and heat transfer systems. Okay. But in this fluid mechanics, you will find that like the closed and like open systems mostly. So these are some examples I think of this open like nozzle, turbine, compressor. All these are the examples. I think all of you are aware of this. An open system basically means a control. This is also called a control volume, open system, which is also called a control volume. Now, why it is called the control volume? Because when there is an exchange of mass, then we called it is a control volume. So basically, a control volume is an open system, basically. And in that case, control surface is means that boundary of that control volume is called the control surface. Okay. And again, as I told you that it can be real and imaginary because it is depend on your study concern basically. Okay. So this can be both. Here we have the examples in these figures. You can see like these are the nodules moving, like moving boundary here. So these are the some examples of this uh, open system, you can say. Okay. This is the case of nodule. This is like the piston in cylinders. Okay, so means how this mass exchange takes place, and when it is called the open system, basically. Okay. Now then comes the dimension. I think all of you are aware of this, but yes, here actually the important part is, I think SI unit all of you are aware of this. Okay, but what is the main point to mention here, that there is just some another unit system like British thermal unit, pound mass, okay, like this pound force, like this. So SI unit, I think all of you are aware. There is nothing to say in the SI unit. I think all of you are aware. But yes, in the English unit, which is means like the British thermal unit, you will actually, why I am discussing this. Okay, first of all, means the question should come in your mind that why there is a need to discuss English unit. Actually, what happens in the book, when you will go with your book, you will find that unit also. That means that English unit there also. So what you will find in that unit, I will highlight you so that you will be aware when you will come with such type of numerical problems. So you must have an idea that what is the difference basically. Okay, so means in the English unit you will find these two term is common, and one more term that I will discuss later. One LBM. LB means basically pound. M is a stand for mass, means pound mass. So you can see here 1 lbm is equal to 0.45359 kg, and 1 feet is equal to 0.304. Maybe some of you are aware of this. Okay. So that SI unit basically mostly used in the engineering. Mostly used. It is I think widely acceptable at the international level. SI unit is widely acceptable at international level. But in somewhere you will find that English units. Okay, so let us take a look. Okay, so that you may not get confused. Okay, if you are getting such type of things in the future. So 1 joule, like here, 1 joule is basically equal to 1 Newton meter. We all know this, and we have a another, that is 1 calorie, like this. So this we also know that 1 calorie is equal to 4.1, and this is very common. But the main difference comes here, 1 BTU, that is called the British thermal unit, which is equal to 1.05 of that kilojoule, means this joule. So this is the relation. Like here, let us take this picture to understand the difference. Okay, here M is equal to 1 kg. In the pound, it is M is equal to basically 32.174 lbm, and 1 feet. When these two will be equal, it will give 1 pound force. Look at here, it is pound force. Here it is 1 Newton. So it means to generate a 1 Newton force, we required a 1 kg of mass 1 meter per second square. But to generate of 1 pound force, we required 1 feet per second with this pound of mass. So that is the main. So here you can see that 1 Newton is equal to 1 kg per meter square, but here 1 lbf is actually equal to 32 lbm mass, then multiply with the acceleration, which is in the term of feet. So you can see here that how these are the related. 1 Newton and 1 lbf, both are the force unit. That Newton and lbf, lbf means pound force, and lbm, this means pound mass. So these are the some units which you will find like here. For more explanation, you can go with this also. Okay, there is no difference, means like here G, we know that G is equal to 9.81. So if you have a 1 kg of mass, okay, then what will be the force here will be generated? It is like 9.807. Okay, and that is equal to like kgf in the kgf term. We have taken 1 kg, and this is our the means kgf means for the gravitational force, means what I am saying, it is for the gravitational force, because here we are taking a g, so g is basically related to gravitational force. So, and that what here initially here, that was actually the acceleration, and here it is the gravitational concepts. Okay, so this is the gravitational concept basically in the terms of gravitational force, and the previous one was a general type of force. Okay, so here you can say that 1 kg of gravitational force, that is equal to, how it is equal to this. So here g means in the terms of that, like here we can see that meter per second square in the terms of meter. In the terms of feet, it is g is equal to 32.174. So for generating like one lbm of this, we required this 1 lbf force, means that 1 lbf force is actually this 1 lbf force is equal to like this, that g is equal to 32.174 like this. So this is how these are the related, and here you can how means you can change that. So we know that this n is Newton is equal to kg, but lbf is equal to 32.174 of this force. So when we'll take that inverse of this will give you like 1 and 1. So in this way you can change, means if you want to change, then the how you can change with the use of this application, means with the, sorry, with the use of these relations basically. Okay, so both are the units, means this units are in mostly in the Indian book you will find this. For the Indian book, you no need to worry about the this pound unit. But for the outside of the Indian book, means for the foreign book, you will find, means that their numerical problem is basically in this unit also. In some question you will find in this, some in SI unit. I think they consider both. Okay, the SI and pound system. Okay, so these are, means this is the easy. It is not the very. It is just a unit conversion. That's all. Okay, the main motive to discuss this unit means because the most of the foreign books consider this unit actually. I think some of you are already aware of this if you have studied the fluid mechanics. Okay, so that you are going to find in the foreign, not for the in the Indian book. You no need to worry, but for the foreign book, because what happens in the international levels, sometimes you need to go through the foreign book also. So in that case, that is going to help you. Okay, so that's why I am considering this, and this is how we have another also, means this is how you can consider this, means how they are equal, like 1 kg is equal to this 32, 1 watt is equal to this. So all this you can see here, this how they are equals. Actually these two are the equal, these three are the equal actually, these three are the equal actually. Okay, so means you can say the real in the their relation. Okay, and yes, before solving the problems, the numerical problems, check the dimensional homogeneity, whether all the dimensions are in the same unit or not. Otherwise, it will give you the wrong answer. Okay, that is the requirement basically. Okay, so it's enough for the day, and now after this we will start our the next. This is what I have we have discussed today is the introduction of this fluid mechanics basically. Okay. After that, we will start now our the statics. Like, so first of all, we will go with the properties of the fluids, then statics like this from the next lecture. Okay. Okay. Now I will take the attendance because there will be another lecture from 2:30. So let me complete this. Okay. Roll number 1 is present. Yes, okay. No need to say. When I will ask, okay, then you need to say. Otherwise, if I'm looking at your name here, but if I will find that okay, you are means you are available online, but you are not present there. So, sometimes I asked, okay, it will be surprise. Uh, Abhishek Kumar, 2 is absent. 3, 4, then others, Ajay, Ajit, Akash, Amandeep, Amar, Amit Kumar. Okay, there is a 2 Amit Kumar. Okay. Anand Jain, Aniket, Anirudh Saini. Okay. Anjali, Ankit, Anand, Archit, Arora, Arjun Bhatia, absent. Then Arshpreet, then Aryan, Arshpreet, Aryan, Ashish Meena, Ashutosh Anand, Atul Kumar, Ayush Garg, Ayushi Sharma, Chaitanya, Charan Kamal, David, Deepak, the Deepak Nan, absent. Okay.
Then, sir.
Present.
Then, sir. Yes, sir.
What is your name?
Sir, real name Deepak Dana, but in MS
Here
Team
it is so.
I entered with
It
Deep
is
Dana.
showing Deep Nan. Okay.
Yes, sir.
Okay. So it is Deepak Nan. Okay. Aniket. Decade Aniket. Absent.
Yes, sir,
Dev.
present. डेकाटे अनिकेत present.
Where? आपकी तो इधर नेम ही नहीं है. कहाँ हो तुम?
तो क्लास में हूँ.
नहीं, आपकी नेम मतलब किधर है? नीचे ऊपर कहीं है?
सर एक्चुअली
शायद
यहाँ पर
नीचे
उसका नेम अनिकेत दिखाते हैं तो वो ऊपर ए वाले नंबर में है.
ऊपर है. एक
Yes.
मिनट, let me check.
सर वो मे भी
अनिकेत-
लिस्ट में डकाते पहले लिखा हुआ है और नेम में निकेत पहले लिखा हुआ है.
ओके, ये रिवर्स कर दिया है. चलिए, आपकी मार्क करनी पड़ेगी मुझे, क्योंकि ये रोज की अटेंडेंस होगी ना, तो आज ये मैं मार्क करता हूँ. एक दीप नयन में प्रॉब्लम है और एक आप में. ठीक है. ओके. देव चोपड़ा वाज प्रेजेंट. यस. देवाशीष, सात्विक, गगनदीप, गौरव, गुरमुख, हमीम खुर्शीद. Hamim Khurshid, absent. Harijay is present. Harmeet,
So,
Harish,
it has left the college.
Harish is absent. Harneet is present. Harsh Bajaj. Harsh Bajaj, absent. Okay. Harshit Hemadri, absent. Hemang Joshi is present. Himani present. Inayat is absent. Ishu is present. JV Reddy, absent. JV Reddy, okay. Karanveer is present. Sitish is present. Harish Lowry Harish is present. Lokesh present. Manisha present. Danis Manshul Goyal, absent. Okay. Danis is present. Mohit Muddit Singh.
So he also has left the college.
What?
So Mudit Singh also has left the college.
Muddit Singh is left. Okay, this is the left case. Okay.
Yes,
Right?
also Himadri Rawat and Hamim Khurshid.
Okay, एक मिनट. Himadri Rawat.
Hamim Khurshid.
Okay, C is a left case. Muddit is also a left case. Habib, okay, एक minute,
Hamim.
just a minute. What was the role of Habib?
Of Hamim, it was 39. Of Himadri, it was 45.
Okay, that was on the previous page. Okay, I will mark. Okay.
So also roll number 100 and roll number 111, they also have left the
Okay,
college.
so let me mark first this left case. Okay, 39 Hamim is left case. After that 39. After that Himadri, then Mudit. After that, who is the next?
Suraj Perwa, roll number 100.
Roll number. Just tell the roll.
100. 100.
100. Oh, just a minute. 100. Suraj.
Yes, sir.
Okay, Suraj is left. Okay, then
111.
111. Varinder is left.
Yes.
Okay. Anyone else? Okay, now let me take the attendance. Okay, fast. It will be late. Naman Gupta. Yes, Naman Gupta is present. Narendra is present. Naresh